Okay, so today we're going to be talking about how to graph reciprocal functions. And so I think the first thing to talk about would be, can you graph the parent function? Okay, so I'm going to scooch this over and we're going to see what we can do here. So if I say, hey, go ahead and graph y is equal to 1 over x, make a table and graph it. Okay, and so the question is, can you? So let's plug in some values to see what we get. So if we plug in 0, wait a minute, you can't do 1 divided by 0, can you? So that's not going to happen. Well, what if you plug in 1? Well, you get 1 because 1 over 1 is 1. What if you plug in 2? Well, that's 1/2. What if you plug in 3? Well, you get 1/3. Okay, what if you plug in a half? Well, 1 over 1/2 means 1 divided by 1/2, or 1 times 2. So it's 2. So if you graph these values, 1 is 1, 2 is a half, 3 is a third, a half is 2, this will give us this graph right here. It looks like there are asymptotes on the x and the y-axis. And that's true. If you plug in negative values, like -1, you're going to get -1, or if you plug in -1/2, you're going to get -2. So these will graph to be this values right here. The shape that you see is a hyperbola, and we're going to be transforming this as if this is our parent function. And so if you can imagine, if you want to move it left to right, you're going to add or subtract from the x. So y is equal to 1 over a minus h. If you want to go up or down, it's going to be plus or minus k to go up or down. And then the numerator is going to be, I don't know why I have this here. Let's take care of erasing this. It's going to be, this is an x minus h plus k. The a corresponds with, normally it's a 1, and if there's a value as the numerator, it's going to be a vertical stretch or compression, or it's going to be reflecting your graph vertically. And so, so we want to say, okay, that's the parent function, the reciprocal function, because no matter what you plug in, it flips it over. We also want to say, let's transform this. Okay, and so let's zoom in and look at these notes. So this is called the reciprocal function because in the parent, whatever you plug in for x becomes its reciprocal. And then there are asymptotes on the x and the y axis. And it's called the hyperbola, and the excluded values are the values that if you plug them in for x, it makes it undefined. And so we're asking first, what are the excluded values? In this first one, x should not be 0. On the second one, we want the values for x that make the denominator 0. So we can set the denominator equal to 0 and solve it. So if you plus 5 to both sides, and then divide by 4, so x should not equal 5/4. Okay, so those would be examples of excluded values. It's where there's going to be an asymptote, a vertical asymptote, because you can't plug in those values for x. And here's the transformations. If the parent is y equals 1 over x, well then the transformational children will be moved based on h, the horizontal component left to right, the opposite of what you see. The vertical component would be up or down. And then also the a is going to be whether it's reflected, and then also a vertical stretch or compression. So moving forward, we can look at some actual graphs and say, okay, can we graph these? And so I think in the first one, we would say, okay, that moves right 3 and down 4 from its parent. So that means the asymptotic grid from the axes will be shifted right 3, and it will be shifted down 4. And so then we would graph it. So the domain, okay, would be, well, or the asymptotes, so the asymptotes. The asymptotes would be x is equal to 3 and y is equal to -4. The domain is x such that x cannot equal 3. And the range would be y such that y cannot equal -4. Because it won't touch those asymptotes. And so what we'll do would be, we need to graph this. So we start with the value you can't plug in for x. You can't plug in 3, because if you try to plug in 3, you get undefined. So you plug in 4 and you plug in 2 on each side, and you can plug them into your right side of your function. So 1 over 4 minus 3 is 1 over 1. 1 minus 4 is -3. Plug in 2, 1 over 2 minus 3 is negative 1, so it's negative 1 minus 4 is negative 5. And if you graph these, because there's no vertical stretch or compression, the next point from the middle of this asymptote grid is going to be up 1 and right 1, and down 1 and left 1 from the middle. And this graph will look like a hyperbola to the left and below, to the left and right of that grid. And unless there's a vertical stretch, that's what's going to be happen. Go over 1 and up 1 and over 1 and down 1 to get to those first points. And so you kind of know what the graph will look like. The second graph is going to be left 1 and up 2, sorry. So left 1 and up 2. So your domain would be the x such that x cannot equal negative 1. The range would be y such that y will not equal 2, because those are asymptotes. The asymptotes would be x equals negative 1 and y is equal to 2. And because there's no vertical stretch or compression, the next points would be over 1, up 1 from that middle. And you could graph this function looking like this. And the weird thing is, like, you can make a table to demonstrate this. Plug in negative 1, you're going to get nothing, undefined, okay? It's a frowny face, okay? And then also you could plug in negative 2 and you can plug in 0 to your function, and you're going to get the values that are going to be diagonal from that center of value. So knowing the transformations, including the vertical stretch or compression, will help you graph this faster. And then the next one is going to be down 4 and a reflection. So instead of it going up and right and down and left from that asymptotic grid, it's going to be in the metaphorical second and fourth quadrants compared to those asymptotes. So it's going to go, the asymptotes will be still here, and they'll be down 4. 1, 2, 3, 4. You should make this dotted. And it will be reflected vertically. And so your points will be to this, basically the fourth and the second quadrants based on this graph. So this is what your graph will look like. There's no vertical stretch or compression, but it is reflected vertically. So you can see it's going to look like this. And the domain would be x such that x can't be 0. And the range would be y such that y cannot equal negative 4, because those are the asymptotes. So if you list the asymptotes, x equals 0 and y is equal to negative 4. And if you make a table, you could start with 0, the bad number. That won't work. And you can plug in 1 and negative 1 to get your actual values for this. And you can plot those points. And the last one we're doing has not only a right 1, but up 2, it's a vertical stretch by 3. Okay, and so if you graph this, you'll notice there's an asymptote at 1, there's a asymptote at y equals 2, and so you can write that the domain is x is not 1, and the range is y is not going to be 2. And then if you make a table, you start with 1, and if you plug it in, you get 3 over 0 plus 2. Okay, that's nothing. Okay, when it's a vertical stretch by something, you should plot like 2 points to the right and left of those values. So if you plug in 2 and 3 and 0 and negative 1, you're going to get some good points. So now, but think about it. If it's a vertical stretch by 3, normally you go over 1 and up 1. In this case, if you go over 1, you're going to actually go up 3 times as high. So 1, 2, 3. Okay, so 3 clicks above the origin. Now, if you plug in 2, and you can use your calculator, 3 over 2 minus 1 is going to be 3. 3 plus 2 is 5. So 2, 5 is indeed this first dot. If you plug in 3, 3 over 3 minus 2 is going to be 1.5 plus 2. 1.5 plus 2 is going to be 3.5. So you should do like 2 points. So 1, 2, 3.5. And you're going to get a pretty good graph of what this will look like if it's right 1 and up 2 in a vertical stretch by 3. That's what the graph will be. Plugging in 0, you get 3 over negative 1. That's negative 3 plus 2 is going to be negative 1. Again, normally it's over 1 and down 1, and now it's over 1 and down 3. And then if you plug in negative 1, you're going to get a half. And so this will be here. Okay, and so that will be your graph. The domain is x not equal to 1, and a range, and I didn't write x such that I should, and then the range is y such that y is not equal to 2. And then you can see the asymptotes as well. So thank you and have a good day.